चलें जी, हमारी क्रोमेटोग्राफी की आखिरी चीज है HPLC, हाई परफॉर्मेंस लिक्विड क्रोमेटोग्राफी। ठीक है जी। बस ये आखिरी चीज है। उसके बाद बायो की चीजें हैं, एंजाइम्स वगैरह और प्रोटीन्स और डीएनए वगैरह, वो अगर तुझे आते हैं तो देन यू कैन स्किप। ठीक है।
जी सर।
ये समझ ले कि ये तुझसे नहीं बस होनी थी, ये HPLC, हाई परफॉर्मेंस लिक्विड क्रोमेटोग्राफी। अच्छा जी, इसको हम लोग HPLC कहते हैं। ठीक है जी, हाई परफॉर्मेंस liquid chromatography. In the high performance liquid chromatography, guys, you people got the mobile phase, that is the liquid, and the stationary phase, that is also liquid. दोनों liquid है। ओके, दोनों liquid है, दोनों। Okay, now what would happen, guys? In this process, basically, this is little bit different from the GLC. GLC, we got gas liquid chromatography, but the scientists thought that if one thing is a gas and the other sample we are taking, that is the liquid, so that does not make sense. So we should use the mobile phase liquid, and whatever the a sample we are using, that is also liquid. So then we should use a mobile phase as liquid. Okay. So now in that case, there are some differences between the GLC and the HPLC. In that case, you take a very small glass tube. This is a small glass tube. Okay. So this small glass tube, my dear, I'm going to make it up here. This is a small glass tube like that. Okay. So this small glass tube, my dear, that is joined with the auto seal rubber in the same way. Okay. And the other part of the tube that is joined with the detector. And detector, this time it also detects the retention time. The same retention time is noted by the detector. Okay. And then this one that is joined with the recorder. So this is the recorder. So whatever the graph that is being made by this HPLC, that is exactly same as we made by, in the GLC, but the only difference lies in the working of it. Why? Because you people are not using the gas this time. Okay. This whole thing should be put into an oven. Okay. So this is the oven. Okay. This is the oven. And the same thing, the temperature of the oven that should be maintained at which any liquid from outside enter that would vaporize. Okay. So up here we got again a non-volatile liquid which is a stationary phase. So this is the stationary phase, and this stationary phase got the non-volatile oil incorporated with silicon dioxide. Okay. So this is the oven. the temperature is maintained at which any liquid entering outside would vaporize. Okay. So any of the liquid, my dear students, that is going to enter in this tube, okay, that would vaporize. So this is the auto seal rubber. So this auto seal rubber, my dear, that is attached with a motor. This is the motor, okay. So this motor, or this is called as the sucking pump, okay. So this sucking pump that is dipped into a liquid, and this liquid up here, that is the inert liquid. Inert liquid. So the inert liquid normally we use, that is the CCl4, tetrachloromethane. Tetrachloromethane does not react with anything. Okay. So this is the inert liquid up here. Okay. So normally what we do, my dear, this is the sucking pump. This sucking pump is going to suck the inert liquid from here, that goes into the oven. As soon as that goes into the glass tube, and this is present in the oven, as soon as this inert liquid enters in the tube up here, it would vaporize. So these vapors, they only consist of the one thing, CCl4. So this CCl4 would be retained by this stationary liquid for how much time? So that time, that is noted by this detector, and the recorder that is going to record it in the form of solvent, like that. So here we got the retention time. Okay. So this is the peak which is being formed. This is called as the solvent peak. Okay. And this is the abundance, my dear. Now what would happen, guys? Whenever you want to find out, let's suppose any sample like juice. Yesterday we have the juice sample. So the same way you should enter the little bit amount of the juice with the help of the plastic syringe up here. Okay, so you just put the this plunger down, so the liquid droplets will come up here, juice droplets. Okay, so inert liquid is coming up here. So this one is going to push these liquid droplets into the oven. So these juice droplets, and this one would vaporize. So these juice droplets, they got different components in it. So those components have got different forces of attraction with the non-volatile oil. Okay, so their retention time for each part of the juice particle, that is different. Okay, so when anything new is going to touch to the detector, detector would forms the peaks like that. Okay, so then I told you the other method, that is exactly same as GL. Retention time or reaction time में क्या difference? Retention time. हाँ, retention भाई दोनों जगह पे retention time है. रिटेंशन का मतलब कि इसने कितनी देर तक उसको रिटेन रखा है अपने आने नहीं दिया जी. रिटेंशन सर एप्लीकेशन तो बिल्कुल सेम है इसका. सर इसका एप्लीकेशन सेम है, सिर्फ फर्क जो है वो यही पे आ रहा है जहाँ पे माइक्रो एग्जैक्टली. मैंने इसलिए नहीं कल ये करवाया था साथ, क्योंकि मैंने सोचा था कि ये करवा के आज साथ पास पेपर के क्वेश्चन करवा दूंगा. दैट इज द रीजन. So now we are going to start with the past paper questions relating to this one. Okay, so let me enter the class and going to share a screen with you people. Okay guys, this is the question. If you look at the question number 13, this is the question. If you look up here, okay, so the first of all you have to write down the definitions of the partition and the adsorption. I told you the definitions of the partition and adsorption. During the process of partition, what would happen? The different components of the mixture, they have got different forces of attraction with the mobile phase, okay, and they are separated due to due to different forces of attraction. So those components which have greater forces of attraction with the mobile phase, they travel further. Whereas those which are having low forces of attraction, less forces of attraction, they would remain. The next thing, my dear, that is the adsorption. Okay, during the adsorption, I told you the components of the mixture, they are having the different forces of attraction with the stationary phase. Okay, so those with greater forces of attraction, they would not travel further. They would remain down, whereas those with greater forces of less forces of attraction with the stationary phase, they travel with the mobile phase very further. Okay. So this is the thing, the separation method, paper chromatography, that is partition, thin layer chromatography, that is adsorption, GLC, that is actually uh, uh, partition again. Okay, if you look the peaks up here, he wants you to find out the percentage, determine the percentage of each of the two components X and Y. I told you should take a scale, okay, and divide this one into two equal parts, okay, and then by using the formula half length into breadth, and this one half length into breadth. Okay, so you should multiply these things with the length. This is the length and this is breadth. This is the length and this is breadth, and then add it up. You will get the area of this one. Let's suppose its area is 30. This one is 80. This one is the 130. Okay, now if you want to find out the percentage of x, you should write 80 divided by 130 plus 80, the total, and into 100. So that will give you the percentage in that particular mixture. Did you get it? सर
या ये तो हमने सपोज की है ना वैल्यू
कौन सी सपोज की?
80 और 130
ओ यार,
Sir,
नहीं और क्या, तुमने स्केल से मेजर करनी है ना लेंथ उनकी यार।
सेंटीमीटर
सेंटीमीटर में कर लो, मिलीमीटर में कर लो, जोन से भी करना है, सेम यूनिट्स रखो। यस माय डियर।
सर मैंने पूछा जब ये पेपर में आएगा ये क्वेश्चन तो हमने ये जैसे आपने अंदाजे से किया ना कि 80 और 130 तो हमने भी इस तरह ही करना सपोज करके।
नहीं नहीं, सपोज नहीं करना, तुमने स्केल से मेजर करना है यार, तुम तो बता रहा हूँ। यू हैव टू मेजर इट विद द स्केल, तुमने स्केल अपने साथ लेके जाना है। ये लेंथ भाई मेजर करनी है, ये स्केल के साथ, ये लेंथ, ये कितने सेंटीमीटर है, ये कितने सेंटीमीटर है, तो वो हाफ लेंथ इनटू ब्रेड्थ को मल्टीप्लाई करो तो इसका एरिया आ जाए।
ठीक हो गया सर।
इसी तरीके से इसका भी हाफ लेंथ इनटू ब्रेड्थ, वो लेंथ ये वाली स्केल से मेजर करो और ये ब्रेड्थ मेजर करो, तो वो इसका एरिया आ जाएगा। इन दोनों को ऐड कर दोगे तो इसका टोटल एरिया आ जाएगा।
और उसको भी डिवाइड बाय दोनों ट्रायंगल के
जी,
एरिया
और इसी तरीके से इसका भी निकाल लो एरिया, स्केल से यू हैव टू फाइंड आउट यार भैया,
फिर एक का टोटल एरिया डिवाइड बाय दोनों का
दोनों का टोटल एरिया। डिड यू गेट इट मुस्कान?
Yes.
ओके गाइस, हैव अ लुक अप हियर। Question number 19A, he is asking you paper chromatography and GLC both rely on the partition of compound between mobile phase and stationary phase. Identify the mobile phase in paper chromatography. Yeah, any solvent, okay? The solvent you use, liquid you use, okay? Suggest what type of liquid is used for the stationary phase in gas liquid chromatography. So what type of the liquid you use? I told you the stationary phase use some non-volatile oil. Okay, so it means that what type of the liquid? So that is the oil. What type of? It's a non-polar liquid. Okay, non-volatile. Okay, oil, non-polar. It's normally non-polar. The next thing, both these techniques can be used to separate mixture state. What you would measure in order to distinguish between the components in the mixture in paper chromatography. What you measure the RF value. In GLC, what you measure the area of the triangle which is being formed. Okay, did you get it, guys?
Yes sir.
Okay, now have a look at this question and give me the answer very carefully. Just read this question, B part. Just read this question. A mixture of three compounds was analyzed by paper chromatography using a non-polar solvent. Non-polar. Non-polar solvent means, guys, that non-polar things dissolve non-polar things more. So we got the non-polar solvent. Have a look at this one. Okay, so non-polar things dissolve the non-polar things more. So the thing which would be at this place, so that would be more non-polar. Okay, so if you look up here, what could be one, two, and three spores? Okay, so which compound is more non-polar? Anybody would tell me? If you look up here, guys, so this one that is having carboxylic acid, C double bond O and OH. This is partial negative, partial negative, partial positive. Okay, if you look this one, CH2 and O and H. So this is partial negative, partial positive. If you look this one, this is C double bond O and OH, and this one is also C double bond O and OH. So this is more polar. Okay, this is more polar. So more polar thing dissolve less in non-polar thing. ओके, तो इसका मतलब ये है कि ये लेस डिसॉल्व होगी, तो ये सबसे नीचे ये रहेगी, तो सबसे नीचे जो चीज रहेगी वो ये लास्ट वाली है। तो थ्री के ऊपर आपका जो है वो कौन सी चीज आएगी, जो सबसे ज्यादा पोलर होगी। ओके, सो दिस वन इज मोर पोलर, तो दिस इज थ्री। और सबसे ऊपर कौन सी जाएगी, जो सबसे लेस पोलर है, तो दिस इज लेस पोलर, तो ये सबसे ऊपर जाएगी और ये नंबर टू पे रहेगी। डिड यू गेट इट? बट सब बहुत आसान है यार, पास नॉन पोलर सब्सटेंस है, वो देखो लिखा भी हुआ है। तो नॉन पोलर थिंग नॉन पोलर को ज्यादा डिसॉल्व करेगी। तो नॉन पोलर पार्ट बेंजीन तो आपका है ही नॉन पोलर, सब में है। कार्बोक्सिलिक एसिड में दो पोलैरिटी वाले ग्रुप है, बल्कि तीन आगे। अल्कोहल गॉट ओनली वन पोलर ग्रुप, द टू कार्बोक्सिलिक एसिड गॉट मोर पोलर ग्रुप। तो जो ज्यादा पोलर है वो नॉन पोलर में कम डिसॉल्व होगा, वो सबसे सबसे शुरू में सबसे नीचे रहेगा। Yahya and Muskan, did you get the concept, बेटा?
Yes.
यस सर।
इस लड़कों से ज्यादा वो होगा।
जी, अगर वो कहता कि polar solvent लिया है, polar solvent, if he say you at the place of this one, if he is going to write, let's suppose if he is going to write up here at the place of he is going to take the polar solvent. So polar solvent dissolve more the polar thing. Okay, so this one that would be then the thing which is more polar. So this one would be one, okay, and this one would be then two, and this one would be then three. Did you get it? If you use the polar solvent here. Okay, guys, did you get it?
यस सर।
Okay, guys, so this chromatography topic that has been finished. Okay, so now what I would suggest you, you got the chromatography thing, on your analytical chemistry topical. I have sent it to you. आपके पास है. What you do? You should do all the question analytical chemistry that has been finished. So what should you do? You should practice all the NMR question, all the questions. So tomorrow, what we are going to do? We are going to discuss the different things relating whatever the questions you got. Okay.